Okay, 28.2. Here we have this equation, and we're going to divide our paper up into the top part of the equation, the bottom part, and then divide the top by the bottom. It kind of helps organize it. So the top part is 3 plus 3 over y minus 3. And the first step with addition or subtraction of fractions is we need a least common denominator. Well, 3 has a denominator of 1 right now. So if we want them to be the same, we got to put our ingredients together. So this one needs the y minus 3. So we're going to multiply the top and the bottom by y minus 3 to make them have common denominators. And when I do 3 times both of those, I get 3y minus 9 over 1 times y minus 3, which anything times 1 is itself, so we won't need to show the 1. And now we have that with 3 over y minus 3. And now we're going to go ahead and just combine things on top that can be combined. And we have a negative 9 or a minus 9 and a plus 3. So we'll continue on with that, and we're going to say we have 3y minus 6 on top, and we keep that common denominator like that. And then we need to see if we can reduce this answer. We're going to factor this top part if we can. We can't always do that. But in this case, yes, we can pull a 3 out of both of those. And we see here, we can't eliminate anything because they'd have to be exactly the same set in order to eliminate. You can't eliminate the y's because they're part of addition and subtraction, and you can't eliminate anything that's part of addition and subtraction unless you can eliminate the whole set. So that's the top part. Now the bottom, we'll do the same thing. We have y plus 2 over y minus 3. We want them to have the same denominator. And this has a 1, just like that one did up here. So our denominator would be y minus 3, that's common. So we're going to multiply both the top and the bottom by y minus 3. So y times y and y times negative 3. So we get y squared minus 3y on top over y minus 3 on the bottom plus 2 over y minus 3 on the bottom. So now put together on top what we can, and really nothing can be combined because they're not like terms. So we'll just write it like this over the denominator. And then we need to ask the question, can this be factored? And yes, it can be y minus 1 and y minus 2 when it's factored over y minus 3. So now we're going to take the top answer and divide it by the bottom answer. That's going to be our third section of our page here. So the top answer was 3 times y minus 2 over y minus 3. And we're going to divide it by y minus 1, y minus 2 over y minus 3. And just like with normal fractions, when it comes to division, it can't be done that way. We're going to have to change this. We're going to have to turn it into multiplication, and we're going to have to flip the second one. That's multiply by the reciprocal. So we're going to rewrite this problem. It's going to be 3 times y minus 2. The first one stays the same. It's the second one that flips. So we're going to, this part, and we're going to say times, the y minus 3 comes up, and the y minus 1, y minus 2 goes down to the bottom. So now we can look at eliminating anything that's alike. You know, just like when we have regular fractions. If I have like 5 over 6 times 2 over 15, I could look at the top and bottom and go, oh, these two both have a 5 in them. Let's get that out of there. These two both have a 2 in them. Let's divide that out of there. So then what you have left is your answer, like that. That's the kind of thing we're doing here. We're saying, okay, anything on top and bottom that they have in common, let's get rid of it. So we have a y minus 2 here and a y minus 2 here. We have a y minus 3 here and a y minus 3 here. So we, again, like what I said up above, we can get rid of things. If they're involved with addition or subtraction, we have to get rid of the whole set, and that's what we did. So now there isn't anything else on the top or the bottom that they have in common. So on the top, all that was left was a 3, and on the bottom is y minus 1. So this would be our final answer for that problem. Now we can go to the next question. Here again, we want to take it with the top, bottom, and divide approach. So the top one is m over g plus g over m. And we want to get the least common denominator, and in this case it's gm or mg, it doesn't matter which way you call it. So this one needs an m on both levels, and this one needs a g on both levels. So now what we have is m squared plus g squared over mg when you put those together. The bottom part, m over g minus g over m. Again, the mg is the common denominator, or gm, so this needs an m to make this have mg or gm. This needs a g, so we always do it on both levels. So this one is m squared minus g squared over mg. Now, if we could factor any of these, we would, just in case there's something in common. This one can't be factored because it has a plus, but this one can. If you factor it, it's m plus g, m minus g over mg. So now we're going to take the top divided by the bottom. So the top is m squared plus g over mg. And again, because we're doing division, we want to turn it into multiplication. So I'm going to multiply by the reciprocal, the flip of this. So I'll put mg on top, m plus g, m minus g on the bottom. And I just noticed I'm not writing things correctly. There we go. This one, I forgot my squared when I brought it down. Got to be careful of those details. They get us every time. All right, so here, none of this can be reduced because this one can't be factored. And if this one is put back together, it's m squared minus g squared. And you can't get rid of parts. If it's involved with addition and subtraction, the whole set has to be the same. So up here, there's no addition or subtraction going here, so I can reduce the m and reduce the g. So what we have left then on top is our m squared plus g squared, and on the bottom we have m squared minus g squared left on the bottom. If the direction said leave your answer in factored form, we'd have to watch that on the directions, but if it says leave it in factored form, then you would want to write this as m plus g, m minus g on the bottom. So then the next one, we're going to do the same thing, the top part, which is x over y minus 1. And hold on just a second, I need to There we go. And then the bottom part is x over y plus 1. So we're going to do those separately again. The top part, we need a common denominator. Right now, this one is y and this one is 1. So we want them both to have a y. So we'll multiply both the top and the bottom by y. So now we have x minus 1y over the denominator. And this is the final answer for this because you can't reduce those y's because this one's involved with addition or subtraction. All right, so we do the same thing to the bottom. We need to give it a common denominator, which is going to be a y. So now we have x plus y on top with a y on the bottom. And again, we can't do anything else to this. So now we're going to take the top divided by the bottom, which means we're going to multiply the reciprocal. So it's going to be, we're going to flip that bottom one like this. And then eliminate anything they have in common. And I can't stress this enough. These cannot be eliminated because they have addition and subtraction. And if they both said minus or they both said plus, then we could eliminate the whole set. But we can't eliminate pieces of anything that are involved with addition and subtraction. So we have x minus y left on top and x plus y left on the bottom, and that's our final answer. Lastly, we have this one. Again, if we deal with the top, and we have 7 over y plus z, and added to 7 over y minus z, then we need to find that common denominator. And what we would have is a combination of the two. The common denominator would be y plus z, y minus z. So this one needs a y minus z on both levels. And this one needs a y plus z on both levels. And I like to put a little dash in my z's so I don't confuse them with a 2. So when you distribute on top, you get 7y minus 7z plus 7y plus 7z, because I was taking, this is what I was doing here to get those. And the denominator is y plus z, y minus z. Now on top, we want to, anything that we can put together, we will, like the 7y and the 7y. So we get 14y. And the negative 7z and the positive 7z cancel out. They're 0. So now we have 14y over y plus z, y minus z. That's our top one. Now for the bottom, all we have is 7 over y minus z, which is squared. And so it's y minus z is what that is. So let's bring it together now and take the top, which was 14y, over y plus z, y minus z. And the bottom, we're going to multiply by the reciprocal. So we're going to put that 7 on the bottom, and we're going to say y minus z, because it said y minus z squared. And now we want to get rid of anything we can. Like 7 and 14 can both be divided by 7. And then we have a y minus z here and a y minus z here that we can cancel out. We can't cancel out this y minus z because there's not another one available. So now we just take everything together. We have 2 times this. So we have 2 times y minus z over y plus z. And that is your answer.